Have you ever noticed how the present feels like a solid place you're standing? Unlike the universe is showing everyone the same now at the same time? What if I told you that assumption is the first mistake? And it's the exact mistake Einstein used to crack reality open. Because when people ask, can you go back in time? They're secretly imagining time as a river with a clear direction, and you as a swimmer who might somehow fight the current. That sounds natural. It also sounds obviously true. And that's what makes it dangerous. Your brain treats time like a single shared stage. One clock, one flow, one global present. But Einstein's entire legacy begins with a brutal message. There is no universal clock. And the present you feel so certain about is not a feature of the universe, it's a feature of you. Here's the unsettling part. Before we even talk about time machines, wormholes, or we have to ask a simpler question that almost nobody asks. What exactly is now? If you and I are far apart, how do we prove we're sharing the same moment? You might say, easy, just check a clock. But whose clock? Where? And compared to what? And that's where the trap snaps shut. Because the moment you try to synchronize reality, you run into the one thing that refuses to cooperate: light. Not as a metaphor light, as the referee of the universe. Einstein noticed something that sounds innocent, but turns into a nightmare. The speed of light doesn't adjust to you. It doesn't care how fast you move. It doesn't add up the way everything else does in your intuition. So if light won't bend to protect your common sense, then something else has to bend instead. And that something is the thing you've trusted your entire life. In the next part, we're going to set up a simple mental experiment. So simple, it feels like a toy where Einstein forces you to watch now split into multiple versions, and suddenly the question isn't, can you go back in time? It becomes back. To which time exactly? If this is already messing with your head, pause for a second and tell me something in the comments. Do you believe there's a single now that everyone shares? Right? One now if you still feel that's true, or write nitrogen monoxide now if you're starting to sense the trap, because if you don't understand this piece, if you keep imagining time as one universal flow, everything else you're about to hear will sound like science. But once the illusion cracks, Einstein's answer stops being a theory and starts feeling like a confession the universe didn't want you to hear. So help me gauge where you are. Comment 1 now, or nitrogen monoxide now. And while you're at it, hit like if you want more videos that don't just explain physics, but change the way your reality feels while you're living inside it. Subscribe too, because what we're about to do next is where most people drop the thread right when it gets disturbing. All right, you ready? Because now we bring in the one thing that forces the universe to reveal its secret. A beam of light and a question that sounds childish until it breaks your definition of time. Imagine something simple. Not a spaceship. Not a black hole. Just a flash of light in the middle of empty space. Einstein loved setups like this because they feel harmless. Until they aren't. Picture two observers drifting past each other in space. No acceleration, no drama, just motion. Now, right between them, a light flashes. Your intuition screams that both observers should agree on when that flash happened. Same event, same universe, same now. But this is where Einstein quietly pulls the floor out from under you, because the universe makes a non-negotiable promise. The speed of light is the same for everyone. Not approximately, not almost, exactly the same. No matter how fast you're moving, no matter who you are, light does not compromise to preserve your common sense. So here's the problem. If both observers measure light traveling at the same speed, but they're moving relative to each other, then they cannot agree on timing. One of them will say the flash happened earlier, the other will say it happened later, and there's no experiment you can run to declare one of them, right? Let that sink in. This isn't an illusion. It's not a trick of perception. According to Einstein, the universe itself refuses to define a single present. Events don't come stamped with an objective now. They only gain timing relative to the observer, measuring them. This is where people usually push back and say, okay, but that's just measurement, right? No, that's the mistake. Measurement isn't distorting reality here. Measurement is revealing reality. The disagreement isn't in the clocks, it's baked into the structure of space. And suddenly, something disturbing clicks into place. If two observers can't agree on what's happening right now, then the idea of traveling back to a shared past starts to rot from the inside. Back. Relative to whom? Back compared to which slice of reality? Einstein didn't destroy time by inventing a machine. He did it by showing that time depends on motion, and motion depends on perspective. And light silent, indifferent light is the enforcer. Now here's the twist most people don't expect. If light forces different nows to exist at the same time, then time isn't flowing. It's fractured, layered, personal. And once you accept that, a terrifying possibility opens up, not backward time travel yet, but something far stranger. Because if time can stretch, split, and disagree, then it can also slow down. And in the next part, we'll follow that idea to its uncomfortable conclusion, where moving fast doesn't just change how you experience time, it changes how much of it you get. Now, take that fractured idea of now and push it one step further, because this is where Einstein stops being abstract and starts messing with your life expectancy. If light refuses to change its speed for anyone, then the universe has only one option left. Time itself must adapt. Not symbolically, not psychologically, physically. This is the part most people nod at without realizing what it actually means. Time doesn't just feel slower when you move fast. It is slower. Picture a simple clock. Not gears, not numbers, just a pulse of light bouncing between two mirrors. Every bounce is a tick. This is Einstein's favorite kind of clock because it can't cheat. Light moves at one speed. Period. Now imagine that clock is moving past you at incredible speed. From your perspective, the light inside has to travel a longer, diagonal path to bounce between the mirrors. Longer path, same speed. The only thing that can change is the ticking itself. So the moving clock ticks slower. Not because it's broken, not because you're misreading it, but because the universe demands it. And here's the part that should make you uncomfortable. That clock could be your body, your brain, your aging. This isn't hypothetical. We've measured it. Atomic clocks flown in airplanes come back slightly younger than identical clocks left on the ground. GPS satellites moving fast and sitting in weaker gravity have to be constantly, or your phone would drift kilometers off target every day. Time, dilation, ISNTA theory, waiting to test. It's quietly keeping your navigation apps honest. So yes, in a very real sense, traveling fast sends you into the future. You experience less time, while the universe experiences more. You don't jump forward, you simply arrive there, having aged less. And this is where the question flips on you. If moving through space changes how much time you get, then chimi isin t, a background river yuhi floating it's something you trade for motion, distance for duration, speed for aging. Now ask yourself something that feels wrong to ask. If time can slow down, why do you assume it always moves forward at the same rate everywhere? Why are we so confident about direction? Einstein never claimed time had an arrow. We just experience one. And once speed starts rewriting duration, the line between past, present, and future stops looking like a straight path and starts looking like a landscape. And landscapes have roots. In the next part, we'll leave speed behind and introduce something even more unsettling because you don't need to move fast to bend time. You just need mass. And once gravity enters the picture, the idea of going back stops sounding like science fiction and starts sounding like a geometric problem. Up to now, time has been misbehaving because of speed. But Einstein wasn't done. In fact, his most disturbing move came when he asked a question that sounds almost childish. What does gravity actually do? Not what it feels like, but what it is. We grow up thinking of gravity as a pull, an invisible hand dragging things downward. Einstein looked at that idea and quietly threw it away. Gravity, he said, isn't a force at all. It's geometry. Mas doesn't tug on time and space, it reshapes them. And when space bends, time bends with it. Here's the unsettling part. The stronger the gravity, the slower time passes. Not metaphorically, not emotionally. Literally, a clock closer to a massive object ticks more slowly than one farther away. Again, this isn't philosophy, we've measured it. A clock on the ground runs slightly slower than a clock on a satellite above Earth. Even your feet age a tiny bit slower than your head. So pause and let that sink in. By simply standing on the floor instead of floating in space, you are already experiencing a different rate of time. You're not just in time, you're positioned within it. Now, push that idea further. Near something extreme, a neutron star, a black hole-less effect becomes violent. Time can slow to a crawl. From the outside, an object falling toward a black hole appears frozen, never quite crossing the edge. From its own perspective, moments still pass. Two versions of time, two equally valid realities. This is where going back in time starts to feel less absurd and more misunderstood. If time bends and warps depending on gravity, then the universe doesn't agree on a single timeline. It agrees on rules, but not on experiences. And once time becomes part of the shape of the universe, direction itself becomes questionable. If space-time can curve, twist, and fold, then earlier and later aren't absolute destinations. They're paths carved into a four-dimensional structure. Einstein opened the door to this realization, but he also left us with a problem that refuses to go away. If gravity can distort time this deeply, could space-time bend so much that paths loop back on themselves? In other words, could the universe contain detours that look suspiciously like traveling to the past? That's where things get uncomfortable. Because now we're not talking about speed or clocks. We're talking about the shape of reality itself, whether it allows shortcuts we were never meant to take. At this point, time is no longer a straight line. Speed stretches it. Gravity bends it. And once something can stretch and bend, a dangerous question becomes unavoidable. Can it loop? This is where Einstein's equations do something unsettling. They don't protect causality. They don't slam the door on the past. In fact, under certain extreme conditions, they quietly allow space-time paths that curve back onto themselves. These paths have a name, closed time, like curves, but the name hides how. Disturbing the idea really is a closed time-like curve means this. If you follow the geometry of space-time exactly as the universe lays it out, you could end up back at an earlier point in your own timeline. Not by cheating, not by breaking physics, by obeying it too well. Now, to be clear, this isn't something you can do with rockets or machines. These solutions appear near objects that twist space-time, violently rotating black holes, hypothetical cosmic strings, regions where gravity doesn't just bend space, but drags time itself around. Think of space-time like thick honey being stirred. If the swirl is intense enough, trajectories can curve backward in time. This is the moment where most people expect Einstein to step in and say, no, this can't happen. But he never did. The equations don't panic. They remain calm, silent, indifferent, and that silence is terrifying. Because if the laws of physics allow loops in time, then the universe isn't protecting the past from interference. It's only making it incredibly hard to reach. The difference matters. Of course, the moment you hear this, paradoxes explode in your head. Grandfather paradox. Causal loops. Effects creating their own causes. And physicists have spent decades trying to patch this discomfort with ideas like self-consistency or multiple timelines. But notice something important. These aren't prohibitions. They're interpretations, attempts to live with what the equations already allow. So where does that leave Einstein's answer, not with a confident yes or no, but with something far more disturbing. Going back in time is not obviously impossible. It's just incompatible with the simple story we want reality to tell. And that forces one final question, the one nobody likes to ask. If past and future can coexist within the structure of spacetime, then what exactly is the status of the present? Because in the next part, we're going to confront the idea that terrifies philosophers more than physicists. The possibility that the entire timeline already exists, and you're simply moving through a slice of it. Now we arrive at the part that doesn't just challenge physics. It challenges your identity. Because once you accept relativity, accept it, you're forced into a picture of reality that feels emotionally wrong. The block universe. The idea sounds simple. It's the consequence. That's brutal. In a block universe, spacetime isn't something that updates. It isn't a stage where the present moves forward like a spotlight. Spacetime is more like a complete, objective, four-dimensional structure where what you call past, present, and future are not locations that come into existence one by one. They're regions of the same thing. And here's why Einstein's perspective makes this hard to escape. If different observers have different nows, then the universe can't privilege one present as the real one. There's no cosmic refresh button. No universal moment where reality becomes real. Each observer slices space-time differently depending on motion. If all those slices are equally valid, then the present is not a global feature of existence. It's a viewpoint. So the shocking suggestion is this. Maybe the future isn't something that arrives. Maybe it's already there, just not in your slice yet. This is where people instinctively recoil, because it feels like you're being told your choices don't matter, like free will is an illusion, like your life is already written into the geometry. But notice the trick your mind is playing on you. It's trying to rescue the feeling of time flowing by turning physics into a moral statement. The block universe doesn't say you're a puppet, it says something colder and stranger. Your experience of becoming is not the same thing as reality becoming. You are inside the block, perceiving it from a moving perspective like a character in a book who can only read one page at a time. The rest of the pages still exist as part of the book, even if the character hasn't read them yet. Now look back at the question, can you go back in time, and feel how it changes. If the block is real, then the past isn't a place that disappeared, it's a region that exists in the structure. Going back would mean changing which region you inhabit or which path through the structure you're following. And that's not just a technological challenge. It's a conceptual one, because maybe the biggest mistake isn't thinking time travel is impossible. It's thinking time is something you move through in the first place. And that brings us to the final pressure point. If Einstein's universe doesn't grant a universal present, and if spacetime might be a complete object, then what protects causality? Why don't paradoxes tear reality apart? That's the last door. And once we open it, Einstein's answer becomes almost poetic. The universe might allow time travel in principle, but it may also enforce rules that make the past untouchable, even if it still exists. This is where everything tightens, because after all the bending, stretching, looping, and freezing of time, you're left with a contradiction that feels unbearable. Einstein's universe doesn't clearly forbid going back in time, and yet reality looks stubbornly consistent. So what's stopping it? The first thing to understand is that physics doesn't care about comfort. Einstein's equations don't contain a rule that says no paradoxes allowed. They simply describe how space-time behaves, and under extreme conditions, those behaviors include paths that point backward. The universe doesn't panic. We do. To deal with that discomfort, physicists propose something called self-consistency. The idea is unsettlingly elegant. If you could go back in time, you wouldn't be free to change anything in a way that creates a contradiction. Every action you take in the past would already be part of history. The loop closes without breaking. That means the past wouldn't be fragile. It would be locked. In this view, time travel doesn't give you power over history. It reveals how little power you ever had over it. You don't overwrite events. You fulfill them. Cause and effect still exist, just not in the order your intuition wants. And suddenly, the classic paradoxes lose their bite. You don't kill your grandfather. You never could. Not because the universe stops you, but because a universe that allows contradictions is one that never forms in the first place. Only self-consistent timelines survive. Now notice how this echoes the block universe. Past, present, and future already coexist. If time travel paths exist, they're part of the structure, not edits to it. Reality doesn't need protection. It's already whole. So when people ask, can you go back in time? Einstein's answer isn't a yes or a no. It's something colder and more disturbing. The laws of physics, Dante, rule it out. But they don't promise you freedom either. You don't get to rewrite reality. At best, you get to understand how deeply constrained it always was. And maybe that's why time travel feels so haunting. Not because it threatens the universe, but because it threatens the story you tell yourself about choice, control, and becoming. If this entire journey shifted how you think about time, causality, or your place in the universe. I want to know what hit you hardest. In the comments, you can write, "The past is locked," or "nitrogen monoxide, escape from spacetime." Those words alone tell me exactly where your intuition cracked. And now there's only one thing left to do: close the loop. If you made it all the way to the end, you're not just watching a video, you're one of the few people willing to let reality feel uncomfortable. So do 3 quick things right now. Hit subscribe, because this channel is basically a guided collapse of everything you think you know about time, space, light, and what now even means. Tap like too seriously because it tells the algorithm to show this kind of deep, mind-bending physics to people who are hungry for more than surface-level explanations. And I want a comment from you so I know you really right. The past is locked if the self-consistency idea stunned you. Or writes nitrogen monoxide real now if the block universe is the thing you can't stop thinking about. If you want to go even deeper, add 1 sentence. Would you try to go back in time if you knew you couldn't change anything? I read the top comments and I'll use your answers for the next video. Now, don't click away, watch the next video that's appearing on your screen because it connects directly to what you just learned. And it gets even stranger. It's the moment Einstein's reality collides with the kind of universe your intuition was never built to handle.